Yeah, so hello everyone. My name is Wanda and my colleague Billy. So today we will present the Hadoop YARN, the state of the union. So first some quick introduction. So for me, I'm an Apache Hadoop PMC member and majorly focus on the GPU and deep learning stuffs for now. Previously, I working on some scheduler features like load labels, preemptions, etc. So, Billy, do you want to introduce yourself?
Hi, I'm Billy. I recently became a Hadoop committer in the past few months, but I've been involved with various other Apache projects since 2011, and most recently I've been working on long-running services and Docker support on YARN.
Yeah, so thanks, Billy. So this is the agenda today. So today I will first talk about the introduction about some very high-level stuffs, and I will quickly cover the past of the YARN, and Billy and I will talk about the state of the union. So what is the current state and what is the future? So we are talking about the multi-colored YARN. So what does this mean? Previously, people thinking YARN is a platform to running batch jobs, such as MapReduce, TEDS, Spark, etc. So what we're going to add is to add the support of the long-running services. So the long-running services is like mostly focused on the data of the long-running services. We are not talking about the running the HTTP servers on YARN. So ideally, people can do that, but that is not the ideal. So we are talking about the data services such as HBase, Kafka, and Flink to handle data. So our goal is to make YARNs becomes a layer which can enable the applications and services and other even higher frameworks to interact with data. So there are some categories of recent initiatives. So first is container, including the Docker container and container orchestrations. And for the computation-intensive applications, we add support of the GPU and FPGA first-class support to do the isolation and scheduling. And since more users and customers are moving to larger and larger scale, so we are improve the scalability of YARN, and we are adding more powerful scheduling to wisely place your containers to the best node. And also we are supporting the more faster scheduling, so which means you can expect less delays. And SLS is very important because applications wants to finish in time, and sometimes if the job don't finish, so the report will not be generated like that. So also as I talked about, we are going to support service load, and also we are consistently improving usability. So I'm going to talk about the Hadoop computation platform, what today's looks like, and what we are thinking tomorrow in the future will look like. So basically, all the applications running on Hadoop and YARN are sharing the underlying platform services, which include storage, for example, HDFS and some S3s, etc. And also the resource management, which include YARN, mostly YARN and some other Docker stuffs. And for the other things, we have service discovery, which makes the long-running services can better running to detect where its own daemons and let the applications use these services. And for the alert monitoring and cluster management, this is mostly for the admin to use. For example, Ambari is tools to do these things. For the governance and security, we need safely to interact with the data. We don't want all the data in the cluster exposed to everybody. So on top of that, we can run applications. We can run the batch jobs like MapReduce, TEDS, Hive and Pig, and Spark. Also, we can run in the long-running services like LLAP, Flink, and Reef. Yeah. So this is today's platform. And for tomorrow, for the future, we want to see that we want to talk about assembly, which means the services and applications running on this platform is not isolated. We want them to interact with each other. Also, for example, if we take the IoT as an example, the platform may need Kafka, Storm, HBase, and Solr to work together. In this case, if we ask the admin to set up these services by their own, it's very hard. It's super hard. That takes a couple of days to set up the IoT assembly like this. So what we're going to support is to only require the admin to write a service spec and submit the service spec to YARN, which include all these services and how they will contact each other's endpoint. So later, Billy will talk about this more. So a very quick history of YARN. So it is a sub-project of Apache Hadoop. And so for the before and now, it is still a sub-project of Apache Hadoop. So we have several alphas and betas before the GA. So the first line of code for YARN is right about June 2010, and we take about 3 years to release the first GA version, which is August 2013. It's how much years? 4.5 years before. So after the GA release, we spent from October 2013 to April 2015. It's about 1.5 years to release 6 minor releases from 2.2 to 7. So this means, so why we release this 6 release? Because the customers wants the most essential pieces for their enterprise usage. So for example, if you look at the features in the red, you can see that it has a resource manager failover, and it has a capacity scheduler preemption. We also have the basic support of the timeline server security, rolling upgrade, etc. So these things are most essential. Without this, YARN cannot deploy in a big cluster or in a production cluster. So for the second, it's about January 2015 to December 2017. It's almost 2 years. You can see that there's only one minor release, which is 2.8 released, and for all the other releases are maintenance release. So this doesn't mean we are stop develop the new features in the background. Instead, because many users and customers are moving to the production usage, they want us to stabilize the release. They want make sure their workload works well. So we can see that we release 7 maintenance releases and 1 minor release. The 2.8 include the features like the application priority and some reservations and some low-level enhancements. And if we look at the last year, from September 16 to August 17, we are working on 3.0 release. So this is the latest major release of Hadoop. And we can also see that from November 2017 to April 2018, and this month, we released 3 minor releases. So with tons of features, which include the resource manager federation, which to support a very large cluster. And also we include the features like opportunistic containers, which to better utilize the resource. So for some of the features, we will talk about later. And also we are adding the new YARN UI for the better user experience, and for the GPU and the FPGA support, and service support, and the placement constraint to better place your containers. So I'm going to talk about a bit about some features we are developing in the past 1 to 2 years. So the first one I want to talk about is application priority. The reason we want to do application priority is in the past, all the applications running in the one single leaf queue, they will receive resource according to the time they submitted. So that means if we submit 4 applications to the queue, the application 2 can only receive resource once the application 1 gets satisfied. So this also means the application 2 may get starved. However, since it is very possible that the user submits a very important application to this queue, they want the application to receive resource earlier. So with this feature, the admin can put a priority to each application, which determines the order of application to receive resource. So if we put the resource from the higher priority to lower priority, so application 4 has the highest priority, so application 4 can receive resource first, and so on and so forth. So, and the next thing I'm talking about is the queue priority, very similar to the application priority, but it is at the queue level. So I will not go too much details, but this means when we have one queue, we can put one queue to running important workload for your application. For example, the interactive queries, which is very sensitive to the delay of resource allocation. So we can assign higher priority to such kind of queues, and which can get satisfied first. And for reservation, so reservation is it means the user can reserve the resource upfront, and so for example, the user may want to say, I want to run a very large batch job at tomorrow 6 a.m. So it will generate a skyline of the workload, which how much resource needs to run and how long this resource needs to be used. And this will be submitted to resource manager. And resource manager will look at its own reservations and decide if the reservation will be take or rejected. If the reservation is take, the application can use this reservation ID to run their job, to get their job launched. And also, this supports recurring reservation, which means you can reserve resource for example, every night from 6 a.m. to 7 a.m. and how much resource you needed. Yeah, so I'm going to talk about the Hadoop 3.0 and 3.1 features. So first is we are seeing that there are more companies are using larger and larger scale of the cluster. So for example, Yahoo, Twitter, LinkedIn, Microsoft, and Alibaba, they're all running very large clusters. So previously, like maybe 2 years before, the largest clusters is about 6K to 8K nodes in the single cluster. And now we see 40K nodes for the federated resource manager and 20K nodes in a single cluster. So we are trying to improve it to better scale. And our roadmap is to scale to 100K and beyond. We don't want to set any limit, so that's why we add the beyond. To achieve this, we are doing a lot of improvement in the scheduler. So previously, the problem of the scheduler is it can only schedule one node at a time. So basically, it can look at one node one by one and decide if the container can be scheduled or not. And this can lead to a suboptimal decisions. And there are some, in the implementation, there are some very coarse-grained lots which can delay the scheduling as well. So what we improved is first is we can look at several nodes at a time. This will be very good for the application needs locality, for example. And also we introduced fine-grained lots. We will rewrite many parts of the scheduler to achieve this. And also we allow the multiple scheduling thread. So with this improvement, YARN can allocate 3K containers per second, which means 10 million allocations per hour. So it is a 10x throughput improvement. So that means previously we can only allocate about 300 containers per second. And also we added much better placement decisions. We will talk about this later. And the second improvement I want to highlight is resource profile and customer resource types. So previously, YARN only supports the first class resource of YARN is memory and CPU. If you want to add any new resource type, it's super hard. You need to change 100 Java classes to achieve that. So that is not ideal for sure. So we added the generic resource vectors. So that means if the user wants to have any new resource, they can just put this to the configuration file without changing any code. And also we added several first-class resources, such as GPU and FPGA for the scheduling and isolation. So the other one is the resource profile. So previously, if the user wants to request a resource, they have to put the resource types, resource values for all the resource types, such as how many memory the application wants, and how many CPU the application wants, and how many GPUs, and etc. But this is not ideal because the user needs to remember lots of things. Instead of doing that, we learned from, for example, the Amazon VM type. We support the lambda resource. So for example, the small means 2 GB of resource, and 4 CPU on vCores, and 0 GPU, like that. So the application can request such lambda resource, so this will be easier for the application to use. So for the GPU support on YARN, so first question is why we want GPU support on YARN, why we need the isolation. The reason is when we have multiple processes to access a single GPU card, this will cause the second one needs to wait the first one to finish before can use the resource. And also for the frameworks like TensorFlow, they will very aggressively to catch the GPU memory. So that means if we allocate 2 TensorFlow process on the single GPU card, the both of the two will fail. So this is very important. And so currently the implementation is the GPU isolation granularity is per GPU device. So why we cannot do the half GPU device? The reason is that the NVIDIA don't have such functionalities to enforce proportion of the GPU to usage. And also we support use C groups and Docker to enforce the isolation. And for the FPGA support on YARN, so it is very similar. It's also for per FPGA device, but currently FPGA only supports C groups for the native process, not the Docker process. And also currently we support the Intel OpenCL SDK, but the implementation of the FPGA is extensible to other implementations. And for the better placement strategy, so this is a very important piece we added to 3.1. So what we support in 3.1 is 2 parts. It's called anti-affinity and affinity. So for the affinity means we want to place one application close to the other. For example, if we have a Storm application and we have a HBase application, we want to place the Storm workers close to the HBase region server so it can get better read performance. So that is for affinity. Sorry. And for anti-affinity, so that means we don't want to place two rows on the same node. For example, if the 2 HBase region server put on the same node or same rack, it may lead to some too much usage of I/O, so they will affect each other's performance. So we can put the anti-affinity constraint here. So this can also can auto-scale if you the application request more containers. For example, if you have 3 containers running for the anti-affinity, the yarn will put the 3 containers to 3 nodes. And now if the application wants to request 7 more containers, the applications will find 7 other nodes to place these containers. And for the later release, we are going to add more comprehensive support, like and or not, and this kind of logics to do the more comprehensive constraints. Yeah, so I'm going to hand over this to Billy to do the following talk.
So before, Wangda mentioned the ability to scale YARN to hundreds of thousands of nodes, and that's possible through the YARN federation capability. Basically, you have sort of separate subclusters of 10 to 100K nodes, and federation will essentially negotiate with the subcluster resource managers to provide resources to the application. And your applications can schedule tasks on any node. So that's our future. I don't think we have any that are at the 100,000 scale yet, but we're looking forward to getting there. So we've also made a lot of improvements to packaging your applications on YARN. I don't know if you've ever tried to package an application for YARN, but typically it would involve getting your tarballs or jars together, some configuration files, and possibly some custom scripts for running your application. And instead of that, we've been looking at using Docker containers for packaging your application. And that is significantly easier to just build a Docker image containing everything that your application needs. And then in a lot of cases, you can use these Docker image to replace, say, virtual machines. So instead of running VMs for your application, you can be potentially running Docker containers on YARN, which is what I'll be talking about in my talk this afternoon. We've added native Docker integration into YARN. The Linux container executor now has the capability on a per container basis for you to choose whether you want to run a Linux process or a Docker process. And that's covered in YARN 36.11. So we've also improved support for services on YARN, and when I say services, we mean long-running applications. So as opposed to the batch jobs, which are designed to run to completion, a long-running service is designed to keep going until you tell it to stop or until it reaches a specified lifetime. And there have been a lot of things done in YARN to support the concept of long-running services. One is the ability to upgrade your services. So you can upgrade individual containers to a new version. There's the ability to simplify discovery of your services. Previously, YARN had the YARN service registry backed by Zookeeper, but DNS is a lot easier mechanism for discovery of services. So now with the registry DNS server, which is built on top of the YARN registry, you can have these sort of user-friendly host names. And these host names are set up when you use the YARN service framework, which I'll talk more about in a minute. The placement policies of affinity and anti-affinity that Wangda mentioned earlier are also extremely useful for long-running applications. Like if you're running an H-based application on YARN, you probably want to spread out the region servers so there's not more than one per node. And container restart or relaunch is another important thing. It's basically the ability, if a container fails, you can restart the container on the same node instead of having to do an entire new container reallocation from the resource manager and start it up somewhere else. So we've also introduced simplified APIs for running services on Yarn. This is actually a simple REST layer on top of Yarn for launching and managing, such as stopping, flexing up or down your services on Yarn. And I'm not sure, you might be able to see this. So on the right, we have an example of a JSON specification that you could post to the REST API or use a CLI command to launch your service on Yarn. You can see there's information such as the lifetime and queue, and this application or service will be running in Docker containers. And you can see the resource specification is also contained in that JSON spec. So the code that's backing this REST API for launching services is the Yarn services framework, which is an AM implementation. So you no longer have to write your own AM to bring your application to Yarn. There's this AM implementation. It's loosely based on the Apache slider AM, but it's actually been completely rewritten for Yarn. The umbrella for that was Yarn 4692. And in addition to being able to launch simple applications, there's a way to use other applications as building blocks to build up a more complex service. So other than the long-running services, there have also been a lot of improvements to user experience. There's now REST API-based queue management. I don't know if any of you have tried to manage queues before, but it's kind of a dark art. But now there's a REST API for doing it, and it no longer has to be done by the cluster admin. There are ACLs for users to be able to manage the queues. And there's also been a lot of different improvements to log management under the umbrella Yarn 4904. But one important one is you can now retrieve live application logs. So with the Yarn logs command, you can get a log for a container that's currently running. We've also implemented a new web UI, which has a lot of nice graphs in addition to the normal application list. This is the applications page. You might be able to tell there's also a tab for services. So the long-running services started by the Yarn services framework will have their own information page on the Yarn UI. And this is the overview page, which has a lot more helpful information. There are graphs of the cluster resource usage by application, so you can tell which applications are using the most resources, as well as resource usage by leaf queue. So another huge thing we've been working on for a while is the timeline service v2. If you think about what the goals are for the timeline service, you want to be able to do application history. So for a specific application, you want to find out where your containers ran, why your application is slow, if it's actually slow compared to other applications, if it's failing or if it's succeeded. But you also want to be able to do history across the cluster. So for all the applications, maybe we want to find the user that had the most resource utilization, or the largest application that's ever been run, or sort of what's going on different in my cluster now than was going on previously. So in general, the goal is to be able to collect and use past data. And with the timeline service version 2, we've learned a lot from the version 1 service. one of the main problems with it is its limited scalability and availability and the difficulty in querying it. So what we wanted for the version 2 is to be able to solve this, both the scalability and querying problem. And we did that by backing it by HBase. So HBase is both more scalable than the version 1 solution, and you can have more of a query language for finding out what's going on your cluster based on this timeline data. And actually, on the YARN UI, the data from the services tab, for example, is pulled from the REST API of the timeline service v2. So that's all of the work we've done recently. Stuff you can look out for the future, in the near future, that will be implemented are node attributes. So node attributes are different from node partitions. In this example, say this is a node partition which has a set of nodes assigned to it, and this is a different partition that has a different set of nodes assigned to it. So each node can only be in one partition. And you can you can specify sort of the queue sharing for a partition. So this has some percentage of QA and QB, and this one has Qs A and B, and a couple other Qs as well. The idea with node attributes is that, you probably can't quite read this, but these 4 nodes have several different attributes. They all have different OS types, but 2 of them have JDK version 8, and 2 of them have JDK version 7. So a JDK version is an example of an attribute that you could use to request certain placements for your application's containers. So if you submitted an application to QA and specified that you wanted JDK version 8, it would try to place the containers on these 2 nodes. And there are no ACLs or shares on the container attributes. It's a first come, first serve. Another new feature you can look forward to is the container overcommit feature. In most cases, the container allocation is going to be different from what the container is actually using. So the idea is to use that surplus space that allocated containers aren't using yet to run other containers. And these containers will be preempted in the case that the original containers actually need to use that space. So it's a feature to have better utilization of your clusters. And another feature that's sort of related to the YARN service framework is the ability to auto-start some specified system services when the resource manager starts. So an example there could be if you're running your HBase instance for ATS, the timeline service version 2, as a YARN service, you want that to automatically start up whenever YARN starts. So for this, basically you have a configured directory, and the RM will read all of the service specifications in that directory and start up those applications when it starts. And these can only be configured by the admin. Yeah, so that's all the information I have for you now. Please come check out my talk this afternoon on lessons learned running a container cloud on YARN. I'll be talking more about the YARN service framework and the Docker capabilities, as well as what we've done with our container cloud. And also definitely check out Wang Do's talk on deep learning on YARN. The talks are at different times, so you can come to both. Do you want to say anything else about your talk, Wang Do? Yeah. Okay. Let's keep the secret. He says, let's keep it a secret. And there will also be Birds of a Feather session tomorrow afternoon, I believe, on... Oh, it's apparently they're this afternoon, but keep an eye out for the Birds of Feather sessions on various topics. Thanks. Does anyone have any questions?
I have a question right away. What are your plans considering this guy and supporting that in YARN?
So the question is, what are the plans for supporting disk.io and YARN?
Yeah, so we do see a lot of use cases for this. So we currently don't have a very specific timelines for that. We starting to consider this year. So any other questions? Yeah, please. So the question is, does the file scheduler also can reach the 10K nodes? Yeah, so for this question, since we are mostly working on the capacity scheduler, I can only say that capacity scheduler can work in that scale, but for file scheduler, they are also evolving. They are trying to add some new features as well. But compared to capacity scheduler, it's still fall behind. Yeah, go ahead.
Yes, that's actually exactly what we're doing with our container cloud. We have a corporate DNS server, and it's sort of delegating one zone to the YARN DNS server. I think the YARN DNS server supports zone transfers and zone forwarding. Yes. But it's a, sorry, go ahead.
Yeah, so to your question, yeah, it is true. But the good thing is, since we just talked about the system service, so that means the admin can configure the system service to run the HBase cluster on YARN prior to all the any other applications to run. So for the end user's experience, so it should be similar. So the end user can see the YARN will automatically run the HBase cluster in the backend.
And also it's a separate HBase cluster that's managed by YARN, so you don't have to run your own HBase cluster.
So essentially you are running, if you have an HBase-based application, technically speaking, you would be running HBase twice.
Yes. Yeah.
So actually, yeah. So this is depends. The user admin can configure to use the original HBase, or use the one launched by YARN. So this is depend. Yeah, please. Yeah, so this is a good question. For network isolation, we have done some part in the last release. So currently what we're going to support is we are going to tag in these packets, network packets. So that means all the packets will have tagging to say which user launched these containers, etc. So the admin can set up some separate IP table rules to do the packets filter. But for the more the network isolation, I think these works are work in progress.
So a lot of the applications we've used use HDFS for persistent storage. For applications that need to store data locally and have that accessible again later, we're kind of still working on that story. That can be done through the registry DNS server. Basically, there will be kind of well-known host names based on the service name and the name of the, say, region server component and the master component. These DNS host names are really useful for configuring your clients and your applications to know where the services running on YARN are. Right, let's see. I mean, I guess typically the application would handle that. So if you're running HBase on YARN, HBase handles its delegation token renewal. I think the AM will do its own token renewal, but I think it's on a sort of application by application basis. Although, let's see, possibly.
Yeah, so resource manager has a dedication token. Yeah, so the resource manager has a dedication token renewal mechanism to ensure the token will be renewed.
Will it do that for each container?
For each application. So basically, application, when it submits, it will have some delegation token submit with the application submission. So resource manager will handle that renewal.
Okay.
Yep. Yeah, maybe it's the last question. I'm sorry?
My question is, can we use Docker executor or second cluster, like Inference now?
Should I take this?
Let's see. Yes, you should be able to do that, although there are kind of issues that we're still working out with respect to the user that is submitting the application versus the user that's running in the Docker container. But we're definitely in our testing, we're running on Kerberized clusters, the Docker on YARN applications. Yeah. I guess that's all we have time for. Thanks for attending.